Organic Shorts.
Oh, yeah.
Hey folks, Mr. Nickel here. We're going to talk about esters today. So esters are probably one of the most confusing to name functional groups that exist in our molecules. The naming rules are as follows. We want to replace the E of the alkane ending. So instead of ANE, we want to change that to AN, and then we want to have an OATE, O8 ending. When we're numbering carbons, esters do it a little bit weird. The parent chain will always be the chain that contains the carboxylic acid. So wherever the double bonded oxygen is, that's the side that we're actually going to start numbering on. That'll be our main parent chain, is wherever the double bonded oxygen is. Wherever the alcohol group, or wherever the oxygen that's intermediating this ester group is, those are going to be a functional group. So in this molecule that I have on your screen right now, this would be a functional group. It would be a separate carbon chain. Now, the other weird thing is when we actually number our carbon chains here, we want to number them as 1, 2. You want to start numbering from that double bonded oxygen. Now, looking at the priority of esters, you can see esters are pretty high. In relation to the ones that we're learning about, they are the second highest priority. Very rarely will we see a molecule with both an ester and a carboxylic acid in the same molecule. If we do, we have this R oxycarbonyl. This R has to do with the enantiomers of the ester. We don't get into that in this class, but you see that we want to have this O8 ending. And so how we'd look at this is we'd say, well, okay, here on the left, I have a 1,2 carbon chain. That's my main parent chain. So I know that 2 carbons are an ethane. And then instead of ethane, I want to change this to an ethane O8. And then as I said, this carbon group over here is actually going to be a functional group. And in this case, it's going to be a methyl ethanoate. So that's the name of this molecule here. Now let's say that we had a molecule that looked like this. If we had this molecule here, you'd be tempted to say, well, on the right-hand side here, we have a longer carbon chain, and so that must be the main parent chain. And that's the confusing thing about esters, is that we still start on whatever side the double bonded oxygen is. And so we still have an ethanoate. We have a 2-carboned ester group. And then on the right, we have a 1, 2, 3, 4, 5 carbon chain there. So this is actually a pentyl ethanoate. And that is how you name and draw ester groups. I hope that was helpful to you.